Hey kids, Mr. Murray here. I'm Mr. Murray's Mathland, and today we're talking about graphing linear inequalities, particularly with two variables. And you can see this first one says y is less than negative 2x plus 3. So you might recognize this. This looks very similar to our equations of line, y equals mx plus b. And that's exactly what we're going to use to graph this. So I'm going to think of it for the moment as if it says y equals negative 2x plus 3. And then we'll just talk about how it differs being an inequality versus a line. So to graph this, I would be starting with the y-intercept of 3, right? And then my slope would be negative 2. So I'm going to go to 3 on the y-axis and make a dot. And then the slope being negative 2, this is a little refresher if you haven't done one of these in a while. Negative 2, remember there's an unwritten denominator of 1. That means we're going to go down 2 and to the right 1, right? Rise over run. Or you could go up 2 and to the left 1 if that's what you have room for on your graph. So I'm going to go down 2 and to the right 1. Down 2 and to the right 1. Down 2 to the right 1. I like to do it a few times, as you know, or up 2 to the left 1 to give myself the best possible graph. And now normally I would just draw a line through that if it was y equals, and then I'd be done. But here's what's different. I'm going to take that line away, actually, because now when you start these, you want to think of two things. You want to think about what kind of line am I going to draw? Am I going to use a dashed or a solid line? And this is the same exact thought process of, do I use an open or a closed circle when you're doing those, simple inequalities, right? So a dashed line is like the equivalent of an open circle, and a solid line is like a closed line or a closed circle. And so if you're good with that, when do we use a closed circle? That's when we have less than or equal to, or greater than or equal to, when it's got the or equal to line underneath. And we'll use an open circle or a dashed line when it's just less than or just greater than. So I'm not including the points on this line as part of my solution. So to show that, I'm going to draw this with a dashed line. Okay, so the dashed line shows somebody that any point that's on this line is not actually part of the solution, because the points on the line are where these two things are equal, right? Y equals mx plus b. And since we're not doing or equal, I don't want to include these points. But now what you've done is you have basically separated this xy plane into two sides. It's like you've drawn a fence. And there's this side and there's this side. One side of the fence contains all the points that are part of this solution that make this inequality true, and one side of the fence contains all the points that are false. So you want to shade the side that's true. The shade is the visual representation of, hey, which side of the fence is the solution. So to me, the easiest way is this, but there's two ways, and I'm going to show you both. So to me, the easiest way is if you have less than or equal, then just think, you're saying, where are the y values less than this line? I'm going to shade under the line or below the line. If you have greater than or equal, you'll shade above the line. So in this problem, it says y is less than, so I'm going to shade underneath the line. So you can start at any point you want. If you have trouble visualizing this, focus on any point on the line and then just shade below it. And now you're just going to shade everything below that line is all part of the solution. So this whole side of the fence, and if you're doing this at home, you don't have to shade in every perfect little bit with your pencil. You can just draw a few lines to show that's the solution side. as long as someone can tell. And that means if you were to pick any point from this side and plug it in, you would get a true statement. And that's the other way to tell which side to shade. If this method that I just mentioned doesn't really quite make sense to you, or you have trouble visualizing what's above and what's below the line, here's the testing the point method. So the second method is to pick any point. Okay, so I'm going to test a point. And you can test any point as long as it's not on the fence. You know, it's got to be from one side of the fence or the other. And 0, 0 is not on the line, so that's always an easy point to plug in, because you plug in and there's not a lot of calculation to do. So when I go and I plug into my original inequality, I just want to see, when I plug in that point, do I get a true statement or a false statement? If you plug in 0 for y is less than -2 times 0 for x plus 3, you get 0 is less than, and on the right side, -2 times 0 is 0, 0 plus 3 is 3. You get 0 is less than 3, which is a true statement. And that tells you that the side that contains 0, 0, here's the point 0, 0, that's the true side of the fence, so shade that side, which we already did, of course. We already shaded the side with 0, 0. If 0, 0 had given me a false statement, that means that's the false side. You'd want to shade the other side of the fence. Okay, so that's the basic idea. Let's just try a couple more to get the hang of it. And each one has a couple more little quirks in it just to watch out for. So number 2, as you'll notice, it's not in slope-intercept form, right? Y is not isolated. So that might be the first thing you want to do, is to get y by itself. So I'm going to subtract 4x from each side, right? Move those x's to the other side. Maybe you're a little rusty in doing that. And we have -6y is less than or equal to -4x minus 6. And now I'm going to divide each side by -6. -6, -6. Now with an inequality, that should be jumping out at you that when we divide by a negative number, we've got to flip the sign, right? We got to flip the direction. So this actually becomes y is greater than or equal to. And then we simplify this side. Normally, negative divided by negative is positive. 4/6 reduces to 2/3. And over here, -6 divided by -6 is positive 1. So there's my new inequality in slope-intercept form. And this is the one I'm going to use when I make my determinations about shading above or below. Notice, I didn't want to look at the original one because that can flip when you divide by a negative. So I always make that kind of decision when I'm right here. And so it's greater than or equal to, so that means I'm going to use a solid line, right? I'd be using a closed circle for that kind of thing, so a solid line. And it's y is greater than. Where are y's greater than a line? Y values are greater above when you go up the y-axis, right? So it's going to be solid. It's going to be shaded above. And here we go. So y-intercept is 1. Put a dot there. The slope is 2/3. Up 2 to the right 3. Or down 2 and to the left 3. Hopefully you're back on board with that. And I'm going to graph this with a solid line. There we go. And now I'm going to shade above. Shade above that line. So start at any point you like and shade up. And like I said, if you're doing it at home, you can just draw a few separate lines like that. That kind of shows where the solution is. You don't have to fill in every crack. Although I remember as a student, I was a little OCD. I like to get it perfectly right up to the line, but hey, that's just me. So there's your solution. And just to give the other idea another try, if you like testing a point, or you might like to do this as a backup to check yourself, testing a point. And the good thing about testing a point is you can plug it into any version of the inequality, either the one you made or the original. So if I plug it into the original one, 0 goes in for x, 0 goes in for y, and I'll get 0 minus 0 on the left side. Is 0 less than or equal to negative 6? No, that's false. 0 is not less than negative 6. Or if you had plugged it into the y isolated one, the y equals mx plus b version, 0 goes in for y, greater than or equal to 2/3 times 0 plus 1. You get 0 is greater than or equal to 1, which is, of course, still false. So what that's telling you is this: here's 0, 0, and 0, 0 gave us a false statement. That means this side of the fence is all points that would be false, so we'd want to shade the other side. And that's the idea there. So you got two ways to get the shading down, and so there's really no excuse to get that wrong. And so here's the last example very quickly. As you'll notice in this one, you'll run into this once in a while. If you remember from graphing lines, sometimes there's only one variable, either just x or just y. And you might remember that means you're dealing with a horizontal or vertical line. And if you remember the little mnemonic hoivux, if there's only an x, that means you're dealing with a vertical line, which has an undefined slope. If there's only y, it's horizontal with a 0 slope. So we're dealing with a vertical line here. And you always want your x, or whatever that one variable is, isolated. So I'm going to divide by 2, and my new inequality says x is greater than negative 3. So here we go. We're going to graph this. It's a vertical line, and I'm going to use the same idea. It's going to be a dashed line because it's just greater than, not or equal to. So just a dashed line like an open circle would be. And so here is a dashed line that's vertical at negative 3. So we go to the x-axis and we make a vertical line right there. Now we've just separated it into two sides of the fence, left side and right side. Now this is the only kind where there's no above or below because it's a vertical line. But this is actually even easier. This is just like our basic number lines we've been doing. Where are the x values greater than negative 3? That would be shaded to the right, right? So that would be everything to the right here. Every point on this side of the fence has an x value greater than negative 3. And if you like, again, the testing method, just to, oops, I'm testing with a dashed line there. If you test 0, 0, if this really is your thing, you want to test 0, 0, well, there's only one x value to plug in, you know, of 0. I mean, there's no y to plug in for. You get 0 is greater than negative 3, which is true, and that tells you, hey, here's 0, 0. That's the true side, so that's the side that gets shaded. If it were false, I would shade the other side. All right, so there's 3 different examples of graphing these. Hopefully, you get the hang of it, and if so, if you got any follow-up questions, just feel free to ask. Take it easy, kids.